Right, so just to recap the different types of reactions, we had our synthesis, which was putting two different components together, like the puzzle piece shows here, and they give a sample reaction for each. This one's a little more complicated than we're used to for synthesis, because you've got the carbon dioxide and the water combining to form the sugar. And then you have decomposition, where you have the sugar breaking down with the help of oxygen into carbon dioxide and water. So literally the same reaction, but backwards, because synthesis and decomposition are opposite of one another. Decomposition is just two chemicals breaking down, like the puzzle piece shows there. Single displacement, you have this dark bead that will replace the light bead, and you have on this side you've got the double dark bead and the light and the dark, and then you see that the one will replace the other. It's like the pairs swap places. I meant to say, I guess you have the two dark and the two light, and then each one here you have one light, one dark, one light, one dark. And you see that in our example here. If you've got potassium iodide and lead nitrate, now we have lead iodide and potassium nitrate. Single displacement, you just have one knocking out the other. And that's what we're going to really focus on today with our activity series, is how do we know if this darker bead will knock out one of the lighter beads. We're going to be able to predict that. And finally, the last one we talked about was combustion, where you have something burning in oxygen, usually forming CO2 and water, but here we have an exception with just H2O. So what I want to do before we look at the activity series is just look at some examples from our homework 8A. So I'm going to pull that up real quick. All right, looking at 8A, we have a whole bunch of equations here. I'm going to ask you, do you see any examples that might represent a synthesis reaction? Any numbers? There's a couple right answers I can see. That's understandable. I'll just kind of walk you through them. One of them I see is this number 5. And I don't know if it's zooming in help at all on that. Number 5 here, we've got carbon plus sulfur gives me carbon sulfide or carbon disulfide. Or even the next one, 6, sodium plus oxygen gives me sodium oxide. You see how those are synthesis. Unfortunately, this worksheet doesn't have any examples of decomposition, but I can just take 5 and 6, put them in reverse, and now I have a decomposition. So carbon disulfide would become carbon and sulfur. Sodium oxide would become sodium and oxygen. How about single displacement? Any takers on that one? Do we see a single displacement reaction? I see kind of a clean one and then a maybe more less obvious one. Yeah, 4. That's a good one. Sodium. That's one that's a little messier because sodium is going to replace the nitrogen out and leave nitrogen all alone. So that's a good example. Also, I'm looking at 2. You have potassium combining with B2O3 to give you K2O and B. How about double displacement? Do we see any double displacement up there? Yeah, number 1, the very first one is double displacement. And I don't see any combustion here, but if we look down, all sorts of examples like 17, 19, 21, those are all combustions because they've got hydrocarbons, and my products are carbon dioxide.